Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to this ongoing online course on Engineering or Architectural Graphics Part 2, and we are discussing about isometric projections here. So, in the past 3 weeks, this is the last lecture of this third week, we have discussed about how to draw isometric views, isometric projection from the given orthographic drawing. Now, what if we have the isometric available? Sometimes the drawings might have misplaced, or for some reason we have only the isometric view available. Can we draw orthographic views out of that? Yes, we can, which is what we are going to be looking at today. So, the process here just reverses. Okay. The only thing we are doing here is we are understanding the parallel lines, whatever parallel lines, and they will have to come parallel and drawing them back in the orthographic. So, understanding where the parallel lines are, in case of curves, identifying where the center of these circles are, identifying where the endpoints of the inclined surfaces are, we will convert them into the orthographic views. So, it is just a reverse process of what we have been doing, and it is very simple. There is not a whole lot of theory around it. We will look at the examples and see how we can really do. I will start with simple examples and we will go on to relatively more complex ones. So, this is the isometric view which we have been given, and now we have to start drawing its top view, which is the plan, front elevation and side elevation. So, let us see. Now, here the hidden lines, the dotted lines are not given. So, assuming that the object behind does not have a hollow or any other shape and it is a solid, we will start drawing this. So, look at it from the top. First we will draw the plan. So, if we look at it from the top, what we are going to see is, so there is a straight line. So, if you look at this, just look at it entirely, this is going to be one straight line. It is in the same plane, vertically it is in the same plane. So, we have to identify, we are looking at this vertical plane, right. So, this is the vertical plane that we are seeing. So, all this is a continuous edge in this vertical plane, because we are seeing it from the top. So, we will have a straight line here, but at a certain distance we will have this, there is one line, at another we will have another line, and this is for the last one. Now, this is at 30, 25 and this total is 100. So, we will take the total distance, say 100, after 30 we have another one, after say 25 we have this one. I will just remove this. So, this is at this reference plane that we get this line. Now, let us look at another reference plane, so which is here. Now, if you look at this reference plane here, what we see that we have an edge, but we do not have any other edge coming, and this reference plane is at certain distance. So, whatever that distance is, we draw this edge, this line, okay, and we have nothing. So, it does not continue further. Now, look at this reference plane which is here, okay. So, this is the reference plane which is here. So, it is at say another distance. I am just drawing a thin line here, not darkening it, okay. What we see that there is no line here, there is no line here. So, we do not draw anything here, but from the top we see that there is a continuous line, this and this is where it is coming. So, I see this is a continuous line and it is continuing all the way up to here. So, this is the line. Now, we are only looking at the planes which are like this. Now, we will start drawing the planes which are vertical. So, like this, okay. So, we see that there is one edge which we will see here like this. At this level we have another one like this. At this level we have a continuous edge which is like this, and at this edge, at this plane we have this small edge, which is what we are seeing here. So, this is the plan of this object which we will get. Okay. Now, we have to draw the elevation from this side. So, there is this arrow which is the front. Now, if you remember the fundamentals of orthographic projection, we say that all the edges should meet in plan as well as elevation, which is what we will draw here. So, what I am going to draw first is these projection lines. Okay. These surfaces are going to remain the same and they are the same reference. Okay. So, I am not going to draw these planes again, but I am only going to look at how the front is going to look like when we see it from this side. Okay. So, these are the planes where we are getting these edges, we know. Now, you look at it in the front and we draw the horizontal plane. So, at this level horizontal plane, we only have this edge coming, rest of the edges will just go continuous. Okay. So, at this level, so at the 0 level, say we have drawn this line which is a continuous line at this level, this and this. Now, at the end we have a surface at this edge. Okay. At this edge, if we are looking at, we have another vertical surface coming with a certain height. At this edge, we have another height which is coming here, and at this level, which is this edge, we do not have an edge here, but we have an edge at the top a little bit. Okay. And now, what we are going to do? We are going to look at the horizontal. So, we have one plane, one horizontal plane here. So, what we see that there is a horizontal plane here, but there is only a straight edge at this level, and this surface and this surface at there is an incline joining, and between these two there is another plane which is going to be joining this. So, now if you look at this, this is the front elevation of this surface, and you can very clearly see that there is one surface here which is this, there is one large surface here which is this. Now, look at it in the plan. We have one surface which is here and which is inclined, which we can see here, and then we have one square surface which is this and another one which is here. So far what we have seen is we have got this exact top view, the front elevation, and now we are going to be drawing the side elevation. We can derive it or we could also draw it. So, what I am going to do here is I am going to first try to derive it just the way we did in orthographic views. So, I am just projecting these lines. If you remember, this is how we were doing the orthographic. I am going to take this up, okay, and now let us try to match. So, this at this level what we have is this. So, this is coming at both these levels. So, a straight line here, right. At this level, so this is the level where we are getting this surface. Okay. So, there is a straight surface here. So, we can get a straight surface at this level. At this level we have a straight surface. Now, in the side view again we will get the same straight surface here, and at this level we will have again a straight surface, but it is going to go behind this line, right, because we are seeing it from this side. So, we will actually have a dotted one here, and in the front we have this vertical surface which is what we are getting here. Okay. Straight, there is nothing, if you look at it from this side, there is nothing which is interrupting this. So, we have this line here, but this line remains absent because this is the line which we were seeing in the top and not in the bottom fully. Okay. So, we are only having this line here in the bottom at this level. So, if I darken it again, this is this complete thing. This is what we are going to get as our side view and there will be a dotted line, because we are seeing the side view, side elevation from this side. So, now you can verify again. What we have is one small surface here, there is this incline here, there is this vertical surface coming here, and then at the back we will also have a horizontal surface which is this. So, this is the rectangle which we are getting and a dotted line, right. So, this is how you can actually, so this is the front elevation, this is the plan and this is the side elevation. So, this is how we can generate from the ISO, we can generate the ortho, vice versa. Let us take another example and try to do the same here. I will draw in light one first. So, we are looking at this front elevation this time. So, if you look at it from the front, let us draw the front elevation first. So, what do we see? I am going to mark different levels. Okay. Then we have this one and we have this one, which is the same plane. So, if you look at this, this is the same plane, this is another plane, this is another plane and this is another plane. So, what I am drawing here is just these lines at different heights, which is what we are seeing here. Okay. This is this one and this is the top one. And let us now draw the vertical edges. Okay. At the front, what we have? There is a straight edge which is this, then a horizontal edge coming down to this level. Okay. This is this edge. Okay. Now, we have another surface here, this is this edge and we bring it down. This is what we have seen in the front elevation. Okay. Now, we see another edge which is this, which is starting from this level and going up to this level, which is this. We see another edge which is starting at this level and going at the third level. So, which is this line. Okay. There is no surface here, there is a horizontal edge here. In the back, there is no surface here, but we just have a line at the bottom level, and there is an edge which is joining this, and then there is another edge which is joining this level and this level, which is this, and at the top we see another edge, right. So, this is what we would see in the front elevation when seen from this side. Let us bring back down to get the plan, the top view. Okay. Now, we have these vertical edges which we have seen here. Now, let us draw the ones we would see in horizontal. Okay. So, there is another one here. If I am drawing it in plan, let us see, this will come here, right. So, we have 1, 2, 3 and 4. So, we have 1, 2, 3 and the end one, say 4 here, and let us try to see what we see from the top. So, there is one continuous edge here, there is one continuous edge which is here, and now what we have is we have another edge at this level which is starting from this plane all the way up to this, and a horizontal edge joining this one. We also have a horizontal edge joining this one, right, which is this line. Okay. Now, what we have is, when we are seeing it from the top, we have an edge which is coming here, just this much, an edge joining these two, which is this. Okay. And then we have an edge which is joining these two layers and a straight edge here. There is nothing here. Now, I am going to remove all these lines which were reference lines. This is what we are going to be seeing from the top when we look at this. Let us try to derive the side elevation. So, we have these lines which will help us arrive at the side elevation. Okay. So, I am just repeating the same process of orthographic projection. Okay, and try to match the points here. Now, what we see here, so okay, so we are seeing the front from here and the plan. So, what we are actually going to see from the side elevation, okay, I should have drawn this side elevation on this side, but right now what we are seeing is from that side, and all we are going to be seeing from that side is this goes as a straight edge. So, this is the point which we have in elevation. If you look at this, this is the point here and at the bottom also. So, this is what a continuous edge is. Now, forget about what we have here. The other point which we have here is this edge, and this point here is both at the top and the bottom. Okay. So, this is both at the top and the bottom, and which is what we will get. So, if we see it from this side, what we are going to get is one block, but behind it we can actually draw the dotted ones. I should have drawn it here, but we will complete this one here. So, now what we are seeing here from that side is, now look at this edge. If you look at this edge, there is a straight edge, okay, at this and this and at this level. So, what we have here is there is a straight edge which is going to come, which is merging with the solid. Now, we also have an inclined edge, okay, which is going to be seen from there starting at that level, and this again here which is at the same point starting at this point and ending at, sorry. So, it is actually starting at that level, but it is starting at this point. We can get it from here, and now we have this one which is coming at this point and starting at this level. So, what we have is we have an incline. Now, right now I am drawing as a solid, but this is going to go back. So, it is going to be a dotted one. Okay. Now, another thing which we have is that we have an edge which is straight, which is going to be seen only as a point here. We have an edge which is perpendicular to the side plane, which is going to be seen, say, somewhere here. If this was to intersect correctly, we would have it passing through this. So, this is the point where we will have another vertical edge going, okay, and this is where we have another vertical one. So, we have a continuous slope, which is what we are seeing in here, okay, and at this level, which is this level in the plan here, this is the point where we have a surface, we have an edge which is coming from here to here. This is how it is going to come, and then the incline and the top one. So, if you look at it, if I have to darken this one, this is what we are going to be seeing in the front elevation. This is what we see in the plan. And if we are seeing it from that side, the front will just be a solid, a flat rectangle, but behind this we will actually be seeing the dotted ones. So, ideally when we are drawing, we should have actually drawn what we would have seen from this side. So, it would have been drawn onto this side. Ideally, the purpose of the drawing is to give entire clarity on how the object is going to be constructed. So, I should have actually drawn it there, but then I started drawing to this side. This is relatively clear, but it is not giving you a full idea as to what this object is going to be, because we do not know exactly that where this dotted line is going to be. The vertical lines are not visible. However, you can still arrive at this if we are going to read all three of them together in at each point we will try to ascertain what is its x, y and z coordinates, but for better clarity we should have drawn it from this side. But this is what the front elevation, the plan and the side elevation of this object are going to be. This is a very simple object, I will leave it to you. You will have to draw assuming that this is the front where we are going to be looking at this, and this is how the side elevation is going to be looked at. So, it is a very simple drawing, very simple object, and what you have to do is you have to draw the plan, the front elevation and the side elevation. You can start from anywhere, whatever you think is most convenient for you to draw, you can draw that, and also you will have to see where conveniently you will get the dimensions. Like in this one, if you start drawing it in the plan, probably you will not be able to arrive at the dimensions. Now, here what they have done is, we know that this is 35 and this is 35, that is the height, and in the base we know that this is 40 and then 15 and 15. This is what we are seeing. We can actually start by drawing the elevation first, because it is easier to understand. If you start drawing it in the plan, you can do that, but it might be little difficult when you have to draw this central rectangle which will come. So, anyways, you can try by starting to draw the plan first or the elevation first and see what you arrive at. This is another object, again a very simple object. You can look at this. I will quickly draw how and where do you start from. We can start by drawing the plan, very simple. We have this plane 1, 2, which is the same plane which is going here, 3, 4 and 5. So, what I will do is draw these 5 lines, okay. And now I have these vertical lines, 1. So, there will be another one, I am just assuming that this radius is in the same line. So, 2, I am sorry, I was talking about the center. So, center is in the same line, 3 and 4 here. We are just ascertaining the centers here, okay. So, 1, 2, 3 and 4, okay. Now, what we have, we are just drawing the plan first. So, what we have is, we have an edge here which is coming here and here, 2 edges, and the end ones here, okay. And from the top we will be seeing a continuous edge with the breaks here. So, this is what we are going to see in the first one. In the second one, you can see that there is a continuous edge like this, which is this, okay. So, which is what we have drawn. Now, for this one we have a straight edge here and here, and at the center of this we also have the center of the circle, the semicircle, which is going to be drawn with the help of this identified center, okay. So, this is what we are going to be seeing in the plan. Now, look at this, take it back to the elevation. So, these lines will remain the same in elevation, okay. So, we just take these lines in the elevation, okay. And now, we will just draw the horizontal lines. So, at 1, 2 and 3, they are just 3 lines. So, 1, 2 and 3. Now, look at it in the front, and what do we get? We get this edge here, this edge here, and what we have? We have to identify where the center for this one is, and we draw a semicircle, which is what we are getting in the object. So, we get this part, okay. In the front elevation for this one, we know that there are 2 of these which are going hollow. So, we mark these, and this is where your dotted line is going to come. This is the hollow, and the rest of it remains solid. So, drawing it as the final object, this is what our front elevation is going to be. In the plan, this is what we are going to see. So, we know that there is a hollow portion here, and we will also mark the centers. Okay, this one, this is what we have to mark, and when you are going to dimension it, you will mention what is the radius of it. Okay, so we will mention what is the radius. You can write whatever that radius is. So, if say R10, and here this is R25, okay, and other dimensions as well. You can derive the side elevation again through these two drawings, or you could draw them afresh, but the reference lines, the ones which are going to extend, will have to be the same. You cannot and you should not deviate from these ones. The reference lines must remain the same. Okay? Take them back, arrive at whatever the side elevation comes when you bring both the views, which is the front elevation and plan together, and arrive at the side elevation. So, do it with the help of this what we have drawn partially, and try to arrive at the correct one, and then match it up here. Okay. So, this is another drawing, another picture here, very simple again, just see the continuity of the surfaces. So, this entire is going to be a continuous surface. So, very clearly we know that if we are looking at in the front elevation, I am sure that there will be a surface which will be like this, which is a continuous surface, right. So, this is a continuous surface which must come, and then the rest of it can be derived from. So, pardon this drawing, but this will be at the same level, and then you will know what are the reference planes, vertical reference planes. So, there are 4 vertical reference planes. If you look at it in the other direction, there are 1, 2, 3, 4, 5 and 6, plus the ones for the circle, okay, which we can also derive when if we are looking at the top. So, we can look at the top view also, the plan first, and start drawing it, but these references will remain the same. So, we will have the same references here, the 6 reference planes plus arriving at the center of the circle. Okay. So, we can do it all the time. What you have to do is the way we did in ortho to iso, identifying the reference planes and then drawing the iso. We will do the same here. In the iso, we will arrive at the parallel lines. Wherever the parallel lines are coming, we are very sure that these parallel lines, which are visible as parallel in the object in the isometric view, are going to be the same in the orthographic views as well. Now, here when we do not have the isometric lines, non-isometric, for example this one, so then what are we doing? We are arriving that by taking the reference planes like this. So, we have the reference planes like this. So, vertical and horizontal. This is how we are going to draw. The same is here. So, we have 2 reference planes here, 1, 2, 3, 4, 5 and 6 here. So, we will be drawing the reference planes. Now, it is only for this one, we also have the reference planes for this part as well. So, this is what we are going to be looking at. Now, see here we have an inclined surface, but then it is going and becoming vertical, which is what we saw here. It is not a continuous inclined surface, it is broken, and here we have taken a vertical at the back. We will arrive at all of these by drawing the reference planes, but correct reference planes, which is our task to identify when we are converting this iso to ortho. Okay. This is a very simple one. We know we are just going to be seeing one continuous surface here. So, a vertical and a horizontal together, and then in the plan when we see, we are going to be seeing 2 semicircles, and there is again one continuous surface which could be may be just one side inclined, but here very clearly we can see from the object that this is a curve. So, we will see a continuous rectangle here. I am just going through these exercises, giving you hints, and I am expecting that all of you will try to solve these problems back at your end. For the circles, the hollow circles here, we will have to identify where these circles are. Now, you may say that what if the circle is not a hollow, if there is nothing which is hollow. If there is nothing which is hollow, we will not be seeing these circles here. Why would they be there? If there is no puncture being done, either it is projected up, it should have had a height. If not a height, then it means that there is a hollow there. So, here there are no dotted lines, but then there are certain things which we have to understand. There will not be any shape just for the sake of it unless there is an edge. A line will be there only where there is an edge. So, if there is a vertical edge and a horizontal edge intersecting, surface intersecting, that is where the edge is going to be created, which is how we will know that this is a hollow, and all we have to do is identify where the centers of these circles are going to come in the reference plane, the reference surface which we are taking. Okay. Again, this is a simple one. What we are doing here, now this is a frustum. Earlier what we did was we drew the frustum from ortho to iso. Here if we have to do this, what we have is, we have a reference plane at this height, we have a reference plane at this height, another one and another one. Okay. And then there is the central axis, so which is going to be here. If we look at it from the top, I would try to solve it from the top first. So, if I identify that this is the central point, which is where the axis is going to pass. The first circle is R10, okay. So, R10, say the first circle, then we have an R15, the second one, the third one is the same, then third one is the same, and then there is a fourth one which is say R30, and the bottom one is going to be the same. This is what we are seeing here, okay, right now from the top, and then we see that there is a hollow, probably it is passing through and through, okay. So, it is going to be a hollow like this, a rectangle, okay. Now, let us take it back to the elevation. What we will do? We will just take this up, straight lines. So, we are doing nothing but just taking them up, and then we also have these 4 planes. So, do not mind the scale, the proportion. So, 1, 2, 3 and 4. Now, at the top level we very clearly know that there is only central circle which is coming. At this edge there is this continuous circle, this edge which is going to be visible. At the third level we have this entire surface which is going to be seen, and at the bottom also we have this edge and this one. And here we have a vertical edge which is what we are seeing as vertical. Now, this is non-isometric, but then we know the reference points. So, this is going to be a slant, and then we also have this dotted coming, which in the view we can see that this is going to be at certain height. So, which is another plane, and then this is, if we are looking at it from this side of front, this is what we are going to see. So, we can actually derive at this, and you can also draw the side elevation, but this is to me this appeared to be easier. If we were to arrive at these dimensions by drawing the elevation first, it would have become difficult, but it is easier to draw the circles in the plane to which it is parallel. The same thing we will draw here. We have circles coming in the elevation, we will draw part of the elevation first and part of the plan first. Sometimes, such as in this case, we may not be able to draw all the objects, all the parts of this object at the same time simultaneously. We might have to draw partly in the front elevation and partly in the plan. So, which is what we will actually be doing here. So, in the front elevation we will be arriving at the circle, okay, and rest of the inclined parts, this horizontal part, and in the plan we will actually be seeing these circles, and then we will take these circles back to the elevation and this one back to the plan, which is what we are going to be doing in this kind of an object, which is very similar to what we are going to be seeing here. Now, you have to identify very clearly. Now, here you can see that there is a surface here, which is this. So, there is a surface here, there is a surface here, then there is a surface here. Now, how do we arrive at this one? So, what we will have to do is actually we will have to bring it back here and like this. So, there is another surface here, which is this, another one here and like this. So, we have identified the vertical slices where we are going to get the lines, and then we will also look at this in the plan. So, we can actually see, we can draw the front elevation from this side, because this is where the curves are going to come. So, we see the curves, we look at the heights where the centers of these circles are coming at what heights from each other. We draw the front elevation, draw these lines in the plan and arrive at the plan and elevation simultaneously working. So, in the previous examples which I was taking, we were looking at drawing one object first, okay. So, just the front elevation or just the plan, but in complicated objects you will have to simultaneously arrive at all the drawings. So, I will stop here today, and with this we have completed all that we had to discuss about isometric projections. In the last week of this course, we will be discussing about the axonometric views. Now, the axonometric views, what are the varieties, what are the types, where are they used, how are we going to draw them, all about axonometric views is going to be covered in the upcoming week. So, thank you very much for joining with me here today. Have a great day. Bye-bye.